In this tutorial, we'll be exploring stoichiometry a little bit further and making sure that you know how to use which number at what time. That's the biggest issue that I've seen with students, is that they have all these numbers in their head and they can't organize their thoughts. So that's what we're going to focus on in this tutorial. A chemical equation, once again, contains conversion factors between moles of reactants to moles of products. It always has to go through moles. We're often interested in things besides moles, like mass or even molecules. And so we're going to focus on grams and molecules in this tutorial. So how many grams of KCl? So I'm looking for X grams. That's our question. Is produced from 2.5 times 10 to the 25th. 2.50 times 10 to the 25th atoms. Alright, so once again, they're giving us information about one compound, and they're asking about another compound. They gave us information about potassium. They want to know about potassium chloride. So we have a horizontal arrow there. Moles are always the end caps of that, because in order to go from one compound to another, you always have to go through moles. And to go from one compound to another, you need to use the ratio. And those are the coefficients. Alright, so now let's look at those other units we have there. Remember to look for key terms. We're primarily going to deal with two numbers, the molar mass and Avogadro's number. If you see grams or the word mass, you automatically know that you need to calculate the molar mass by looking at the periodic table. If you see the words atoms, ions, molecules, or formula units, you know you need to use Avogadro's number. Here we have atoms. To go from atoms to moles, we're going to use Avogadro's number, because that's the key term for it. Over here we have grams. For grams, we're going to use the molar mass, which means we need the periodic table. So we have K and we have Cl. K is over here, 39.1. And Cl is right here, 35.5. We have one of each. Ignore this 2. The only time you ever use that 2 is during the coefficients. That's a major mistake that I see with students, is that they want to use that 2 in multiple places. There's only one bracket and at one time that you use that 2. And that's during going from moles of one to moles of another. So when we're looking at the molar mass, we only focus on the compound itself. We add these two numbers together, and it comes out to be 74.6. Alright, so here is our plan again. We're starting off with 2.50 times 10 to the 25th atoms. We're going to use Avogadro's number to get to moles of potassium, use the coefficients to get to moles of potassium chloride, and then use the molar mass to get to grams of potassium chloride. Now that we have it all set up and organized, we can take the time to set it, we can actually calculate it out. Once again, the number that's in the question is the number that's going to go over 1. So 2.50 times 10 to the 25th atoms of potassium. Atoms of potassium are on top. That means I want to put atoms of potassium on the bottom. Notice we're right here and we're trying to get to right here. We're trying to get to moles of potassium. We're going to do that by using Avogadro's number. 6.02 times 10 to the 23rd. I always run out of room when I do these. That's per mole, so that means 1 mole. The atoms of potassium can cancel out. So now we have it in moles of K, that's where we're going from, and we're trying to go 2 moles of KCl. To go from one to the other, we're going to use coefficients. So the number with K is 2, the number with KCl is also 2. We are right here in our plan now. We need to go from moles to grams. So we're going from moles of KCl to grams of KCl. To do that, we're going to use the molar mass. For grams, 74.6 goes with grams, and it's per 1 mole. So to calculate this out, it's going to be 2.50 times 10 to the 25th divided by 6.02 times 10 to the 23rd times 2 divided by 2 times 74.69. That comes out to be 3.10 times 10 to the 3rd grams of KCl. The key is to know when to use which number. And the key of being able to do that is to look for the key terms. Alright, so let's try another one. How many atoms of iron, that's what we're looking for, is needed to react with 16.0 grams of sulfur? That's supposed to be underneath the sulfur. Alright. So we have 16.0 grams. We're being asked about iron, but we're being given information about sulfur. So we need a horizontal line here to go from one to the other. Moles are the end caps. To go from one to the other, we're going to use coefficients. The initial number is given in grams. To go from grams to moles, we're going to need the molar mass. 32.1. It's 8, so 8 times 32.1 is equal to 256.8 grams per mole. Now on the other side, we're going from moles to atoms. Atoms is the key term for Avogadro's number, 6.02 times 10 to the 23rd. So we're going to go from grams to moles of sulfur using the molar mass, then moles of sulfur to moles of iron using the coefficients, and then moles of iron to atoms of iron using Avogadro's number. Alright, so now that we have it all set up, we can put it into the equation. Our initial number is 16.0 of sulfur over 1. Where we're going from is sulfur. So we're going from here to here. So grams of sulfur will be on the bottom. Moles of sulfur, where we're going to, will be on the top. So look at our conversion factor. 256.8 was off the periodic table. We calculated that. Is per mole, so per 1 mole. Now we're here in our plan. We go from moles of sulfur to moles of iron. Where we're going from goes on the bottom. Where we're going to goes on the top. We use the coefficients now. There's an invisible 1 for sulfur, and there's an 8 for iron. We are right here now. Now we're going to go from moles to atoms. To moles of Fe to atoms of Fe. I should have given myself more room. Alright, so here's our conversion factor. For moles, it's per mole, so it's 1 mole. And then for atoms, it's 6.02 times 10 to the 23rd. It's Avogadro's number. Alright, so grams of sulfur cancel. The moles of sulfur cancel. The moles of iron cancel. We're left over with atoms of iron. Remember, what you're looking for will be in the last, on the top of the last line. So it's going to be 16 divided by 256.8 times 8 times 6.02 times 10 to the 23rd. That comes out to be 3.00 times 10 to the 23rd atoms of iron. We're going to try one last practice problem. This one's a little bit different, so be cautious about that. When 1.20 moles of ammonia reacts, the total number of grams of the what's the total number of grams of the products that are formed? So let's look at this. We have 2 products here, so we're going to have 2 different questions with 2 different answers. So we want to know this one, and we want to know this one. Keep that in mind. So that means we're going to have two conversions here, and then we're going to add them together at the very, very end. You cannot do this all in one line. Alright, so NH3 to NO2. Moles are the end caps. In order to go from one to the other, you need coefficients. Now, our initial number is actually already in moles, so we don't even have to convert that. We just have to focus on the NO. So we have nitrogen and we have oxygen, 14 and 16. Add that together to come up with 30 grams per mole. Now we're going to do the same thing with water. Moles are the end caps. Once again, our starting number is already in moles, so we don't have to convert that. But look over here, we're in grams. Grams means molar mass. So that means I need to figure out the molar mass of water. So we have 1 times oxygen, which is 16. And we have 2 times hydrogen, which is 1. These are all 0.0, by the way. To be 18.0 grams per mole. Alright, so there's our plan. Notice we have two sets. We have two starting points. That means we're going to have two equations when we're done. So let's focus on nitrous oxide first. 1.20 moles of NH3 over 1. We're right here. We need to go from moles of NH3 to moles of NO. To do that, we use the coefficients. There's 4 in front of the NH3, and there's 4 in front of the NO. Now we need to get from moles to grams. There's 30.0 grams per mole. So this means it's going to be 1.20 times 4 divided by 4 times 30. That comes out to be 36 grams of NO. That's one of our products. We need to figure out the other product now. So we're going to do the exact same thing again, the whole thing again. It won't let me put a decimal there for some reason. Alright, so we're right here in our equation. We need to go from moles of NH3 to moles of H2O. So we're going from moles of NH3 to moles of H2O. Alright, so we look at the coefficients to do that. There's 4 for NH3, and there's 6 for H2O, because we're going to H2O this time. We're right here in our plan now. We're going from moles of H2O to grams. So for 1 mole of H2O, we're looking for the molar mass, which is 18. There's 18.0 grams of H2O. So it's going to be 1.0 times 6 divided by 4 times 18 to equal 32.4 grams of H2O. What we have to do at this point is add these two together to get a total mass. So 36 grams plus 32.4 grams is going to equal 68.4 grams. Hopefully this has helped you to understand when to use which number.